In this video, our goal is to understand the saving investment model, assuming that we are dealing with an open economy. And we'll use the analytical framework as well as we'll draw parallels with the numerical framework to try and understand this model and try and associate how these two frameworks can be used to drive the main outcome of the model. So let's begin with the model setup. And in this model, we have the total output as a function of capital and labor, right? And capital and labor are both exogenous, so output becomes exogenous. In a numerical framework, the model setup, when we say y bar is exogenous, it boils down to y taking some value, let's assume 18,000. And from the demand side, we have consumers, we have investments, and we have government spending. Now, government spending is exogenous, and so taxes are also exogenous. The consumers, um, the autonomous part of consumption, we'll call it constant of consumption, is exogenous, obviously. And then the every time we get this extra income after you pay taxes, you increase the consumption by cy, so cy becomes your mpc. Similarly, investments will have two components, that part which is constant, which is not related to interest rate, and then that component which is related to interest rate, right? Now keep in mind, we are dealing with open economy, and in an open economy, our domestic interest rate will be equal to the foreign interest rate. And that is because we are assuming three things. The first being that domestic and foreign bonds are perfect substitutes. So it carries the same amount of risk and same amount of maturity across different countries. And then we are also assuming that there is no restriction on mobility of capital. So there is a perfect mobility of capital. And given the fact that there is a small open economy that we are assuming, and these three assumptions boils down to R equal to the foreign interest rate, and foreign interest rate is exogenous, right? It's exogenous because we are a small open economy, and because that is a perfect substitute of these bonds across different countries, and there is no restriction on mobility of capital. Obviously, because of arbitrage, there is no reason for us to believe that the interest rate in our country or the small open economy will not be equal to the foreign real interest rate. So in terms of numbers, we have C, which is, let's say, 300 plus zero point 0.8. 0.8 is our MPC, Y minus T. And then investments are, again, let's assume that part which is not related to interest rate is 5,000. And then minus 400 R, telling us that every 1% increase in R will lead to lowering of the investments by 400. So this minus 400 is similar to IR in the analytical framework, and 5000 is same thing as IC in the analytical framework. The government spending is just again exogenous, so we are just going to assume it's a number. So that's 3000, again making up these numbers. And let's assume taxes are equal to 2500. Right. Now notice we need to still specify what is our world interest rate, because that is the interest rate that will prevail in our small open economy. And let's assume this world interest rate is 5, that is 5%. Now obviously we know that the national savings of a country is equal to the national income, which is represented by this Y, minus the private consumption and minus the public spending. So this is the private spending C, this is the public spending, and so the national income minus the spending, the total spending becomes the national savings. So in terms of numbers, we'll just use whatever values that we have assumed. So y is equal to 18,000, and then c is 300 plus 0.8, 18,000 minus 2,500. 2,500 is your taxes, and then minus your government spending, so that's 3,000. Then when you do the math, our savings will equal to 2,300. Now in equilibrium, keep in mind we are now an open economy, so the total production or output is equal to C plus I plus G. If this was a closed economy, we would have stopped there, but now because we are having trade with other country, we have NX. And so when you move the terms, you get this same expression of savings, y minus c minus g, and then minus I is equal to nx. So this expression out here, y minus c minus g, is your s minus I, that is your nx. Now this is very interesting. This is nothing but our trade balance, and this saving minus investments is our what is known as net capital outflow. So in the numerical solution, let's see what is the equilibrium value of the net exports and the savings investment gap. So our y has to equal to c plus I plus g plus nx, right? That is the same. And then y minus c minus g minus I, that gives us nx, and that is s minus I equals nx. We know our savings is 2,300, and then investments is 5,000 minus 400, and then times r. R is equal to r star, which in our example is 5, and that is equal to our nx. So when you do the math, this is 5,000 minus 2,000, so that's 3,000. So 2,300 minus 3,000 is negative 700, is going to be our balance on our trade account, which is nothing but the trade deficit of 700.